All right, for today's lesson, we're covering the properties of multiplication and division. We covered addition and subtraction already, so now we're getting into that multiplication and division component. Our learning target is that you can apply properties of multiplication to solve rational number multiplication and division problems. So rational numbers, those are things like our integers, our positives and negatives and zero. It also includes your decimals that terminate or repeat, and fractions that can be rewritten into decimals that terminate and repeat. So we'll talk more about that a little bit later. But properties of multiplication, you got the same exact verbiage as you do with the properties of addition. Remember when we had properties of addition, we talked about associative property, which was how we group it. We had commutative property, which was the order that can change. But then we also have distributive property, which combines multiplication and addition together, or multiplication and subtraction together, by distributing a value as a product to components that are on the inside. So for example, if we've got 4 times the quantity of 1 plus 2, then that means I can do 4 times the 1, and I can also do 4 times the 2, and then I can take the sum of those products together. Okay, so distributive property basically is like if I've got papers that I want to hand out to my students in the classroom. I'm going to hand it to every single student inside of this class. Am I going to hand it to the 6th grader that's walking in the hall outside my classroom? No. Okay, I'm only distributing it to what's inside of my classroom. That's kind of like the parentheses. The parentheses are creating a setting that whatever is getting distributed gets distributed only to those components that are on the inside of that setting. Okay, so distributive property uses multiplication, and it multiplies to every term inside of those parentheses. Then you've got your identity property. We had an identity property for addition that stated if you add a 0, it'll keep the value the same, that no matter what your value is, when you add 0, it doesn't change anything. The identity for multiplication is not a 0, it's a 1. If you multiply any value by 1, it'll always stay the same. No matter what that number was, when you multiply it by a value of 1, it remains the same. We also have a 0 property that if you multiply any value by 0, you're always going to get what? 0. Okay, so no matter what you multiply by, if you multiply it by 0, it's going to become 0. Okay. And just like we had an additive inverse, we have a multiplicative inverse too, or the inverse property of multiplication, which means that if I take a value and I multiply it by its reciprocal, otherwise known as dividing by that value, it'll come out to 1. Okay, so if I do A divided by A, it's the same thing as saying A times 1 over A. And that's going to give me a value of 1 whole. So division is just the same thing as the multiplication's inverse. Okay, if we take a value 36 and divide it by 4, we're technically multiplying by the reciprocal of 4. So 36 times 1/4 and 36 divided by 4 will equate to the exact same thing. So these are some properties or rules that is really important for you to understand. Just like we did with the addition and subtraction, we're going to look through some problems and identify what type of properties could be utilized for each step. So I want you to go ahead and flip it on over to the back. I want you to take a look through each one of these steps, starting with the very beginning of what the problem was. When we go from the original problem down to step 1, what property or justification happened to be used? And then when we go from step 1 down to step 2, what was the justification or property that was used, and so on and so forth. I want you to go ahead and fill out this table on your own. So taking a look here, we're going from step 1 to step 2. Who can tell me what property or justification occurred here? Kingsley? The inverse property of multiplication, or a multiplicative inverse. Okay, what's happening here is that we started off with division and then it changed to multiplication. So we multiply by the reciprocal for not just the first step, but also for the second term set. So both of these got changed to multiplication. So what we were doing is it was the multiplicative inverse or inverse property of multiplication. You can use either one of those terms. Okay, from step 1 to step 2, this was not a property. This was not a property. All that happened is we just actually multiplied. All that occurred here was actual multiplication. So step 2, we just multiplied 8 times the negative 3/2. That's the only thing that actually occurred in this step. Okay, but then going from step 2 to step 3, what property happened, Caleb? Associative property. So located right here, we are seeing an associative property that occurred. Originally, we had that being negative 12 times the 7 times the 1/2. Well, now we've created a grouping. We've created a grouping. So when we group things or we change something that's inside of a group, then that's going to go ahead and become the associative property. We're associating things together. So this is associative property. Okay, then again, here comes that multiplication that's occurring. We're just doing negative 12 times the 1/2 to get that negative 6. That's the only thing that actually changed within the problem. So it was just multiplying. We multiplied negative 12 times the 1/2, and that gave us that negative 6. Okay, so now we went from negative 6 times 7 times negative 3 to negative 6 times negative 21. Again, it's just multiplication. It's just multiplication that's now occurring here. So this negative 21 has become a new value. So we're just multiplying here. And then last step, it's just multiplication again. And they keep giving us the wrong stuff on that form. That should be a positive. That should be a positive 121. Or I mean, 126. I need to make a note to message them. All right. We're going to go down to this one here, applying distributive property. We can apply the distributive property even when it's just a whole number multiplied by a mixed number. Remember, we can split a mixed number apart by pulling the whole number and the fraction separate. Okay, we can separate the fraction and the whole number and do some multiplication that way. So I'm going to go ahead and rewrite this where I have negative 10 is going to be on the outside of a quantity, and the quantity that's going to be on the inside is my whole number plus my fraction. So I'm doing 2 plus 3/5. And what distributive property states is that I can take this negative 10 and I can multiply it to the 2. So I can do negative 10 times 2. And I can also do negative 10 times the 3/5. Okay, what is negative 10 times 2 going to give us? Go ahead. Negative 20. What about negative 10 times 3/5? What will that give us? Negative 6. You can use your calculators, it's perfectly fine. And then we can combine those together. Negative 20 times negative 6 becomes negative 26. Okay, so that makes it a lot easier when you are dealing with a mixed number being multiplied by a whole number. It's easy to break that mixed number apart to break that mixed number up and then do a distributive property for multiplication. Sometimes you won't have to worry about it. Sometimes they already have problems split apart. So like the third problem all the way through the sixth problem, they have stuff separated out. So we're going to have you, I'm going to do one more with you, the one where we're splitting, and then you guys are going to do the rest of them on your own. If I'm taking this negative 14, and I'm going to split up the negative 3 and 5/7, this is going to become negative 3 plus negative 5/7. Both the 3 and the 5/7 have to be negative in order for the whole thing to have been negative. And then I can do my distributive property. So I can go ahead and multiply negative 14 times negative 3. Remember, a negative times a negative gives us a positive. A negative times a negative gives us a positive. So we're going to get a positive 42. Then we're going to do negative 14 times negative 5/7. That's going to come out to a positive 10. And then we can add those together, and that's going to give us 52. I want you guys to do the rest of them on your own. Taking a look here, when we are distributing, we're going to do negative 5 over 7, and we're going to multiply it by 10. Plus negative 5 over 7 times negative 1 over 5. Okay, when we do negative 5 over 7, that's going to come out to a decimal that's going to keep going on and on and on. So we're going to leave it in fraction form. This is going to stay negative 50 over 7. Plus, when we multiply here, we're going to get a positive 1 over 7. Okay, when we combine these together, that's going to equal negative 49 over 7, which would then simplify to just negative 7. So you should have gotten negative 7 as your answer. Okay. All right, for the next one, we're going to distribute. We're going to do negative 1/3 times 6 plus negative 1/3 times negative 4/3. When we multiply negative 1/3 times 6, that comes out to negative 2. When we multiply negative 1/3 times negative 4/3, it's going to come out to a positive 4 over 9. When we combine those together, that's going to give us a negative 1 and 5/9. Okay. For the sake of you being able to start your assignment, I'm going to stop here. I'll fill in the rest of these later, and you can have you can see them online. But I'm going to stop here so that you guys can get into your assignment.